So to do bitwise subtraction, one thing that we can always observe in addition or subtraction, both of them, is when you subtract 0 and 0, you should get 0. When you subtract 1 and 1, you should get 0. When you subtract 1 and 0, you should get 1. When you subtract 0 and 1, you should also get 1, but with a borrow, right? So this is how it is. Now the old so we see that when we 0 and 0, we should get 0, 1 and 1, 0, 1 0 1 0 1 0. That means whenever we have the inputs 0 0 same, whenever we have the inputs same, we should get 0. When you have different inputs, we should get a 1. So looking at all the gates that we studied, we know that the only gate which satisfies that is XOR, exclusive OR, which is the only gate which gives you a 0 when the two bits are the same, and a 1 when two bits are different. So this to just get this answer, we can use an XOR. Now this is the same thing with addition also. In addition and subtraction, both of them we use XOR. But the difference comes when we take into consideration the borrow. In addition, we had to do the same thing XOR, but to take into consideration the carry. But here what we need to take into consideration is the borrow. So the next aim is how to find the borrow. So for that we need to just go back and see how we actually do our decimal subtraction. So suppose I have two numbers, 42 and 27. Okay, I need to subtract them. Now what actually happens in subtraction is that it is manually difficult to subtract 2 and 7. So therefore we borrow a 10. Why a 10? Because 4 is in the tens place. 4 is in the tens place, so we borrow a 10 and we add it to 12. So this actually becomes 12. I mean this side becomes 12 minus 7, and we do the calculation, and this is just for the calculation that we borrow. Once the calculation is over, then we return it back. Okay, so 12 minus 7, that gives you 5. So you write the answer here, 5. Then you have a 4 and 2. Okay, you 4 and 2, you get 2. But we know 25 is not the right answer. And why it is not right? Because we borrowed a 10. You see, we borrowed an X. It is not there in this 42. I mean, it is not there in this ones place of 2. But we borrowed an extra 10. So therefore, what we borrowed, we had to return it back. So subtracting the 10 that we borrowed, we will get 50. And that is the right answer. 42 minus 27 is 50. And this is the same, exactly the same. If we suppose you're using 427 minus 138. Okay, you need to subtract these two things. Now what do you do? Okay, leave this for now. 7 minus 8, you cannot do it manually, so you need to borrow from this thing. Okay, you need to borrow a 10 from 2. Okay, so first of all we borrowed a 10, so let us just write it here. We need to subtract a 10 because we borrowed a 10. Okay, now since we borrowed a 10, this becomes 17. 17 minus 8 17 minus 8, and that gives you 9. So we write 9 here. Then next 2 minus 3, again it is difficult, so you need to borrow from here. So while you borrow from here, now this 4 is in the hundredths place, right? Ones place, tens place, hundredths place. So you are borrowing 100 actually. You're borrowing 100. So while you're borrowing 100, this becomes 100 this becomes, and 2 is already in the tens place, so you're borrowing 100. 2 is already in the tens place, so it becomes 127 actually. And then you're subtracting 38. This side is already done, so you are subtracting 12 minus 3, which is again 12 minus 3, which is 9. So you do a write a 9 here again. Now so we borrowed 100, so we had to subtract 100. So we'll write that also, subtracting 100. Now 4 minus 1, which is 3. Now we need to do the extra. What were the extra borrowings? We borrowed 10, we borrowed 100. So subtracting 110, what will we do? So subtracting 10, we will get 399 minus 10, you get, and minus 100, you get 289. Right, 289. Now if you check, you will see that this is the right answer. 427 minus 138 is 289. So this is actually how subtraction works. I mean, even though many of us, at least many of us didn't study subtraction that way, this is how subtraction works. Now using the same logic in binary, what happens? You have two numbers, 1 0 0 1 0 and 0 1 0 1 1 0. Okay. You need to subtract them. Now we know that the answer that you actually should get is, so subtracting these two things, you are supposed to get 0 1 1 0 0. That's what you're supposed to get. But to get this, first we need to do our XOR operation. To do the XOR operation, so while doing the XOR operation, we get 0 0 0 gives 0, 1 1 gives 0, 0 1 gives you 1, 0 0 gives you 0, 1 0 gives you 1. So from this we need to get to this. Okay, now one thing that you should notice is, where all should we get the borrow? A borrow actually happens. This is just the XOR answer, this is the real answer. Now a borrow happens here where there is 0 and 1. Okay, in this question only here, where there is a 0 and 1, that is where we get a borrow. And what is borrowed? A 1. Then we are borrowing it from the next digit, the next consecutive digit to the left. Right, so we are borrowing it actually from here, from the next consecutive digit we are borrowing. But again, for now, just consider that it is at this place, whenever a 0 and a 1 comes, that we need a borrow. Now there is no logic operation that gives us a different kind of output for only 0 and 1, because we should not get a borrow when you have 1 and 0. We should only get a borrow when you have 0 and 1. So that disqualifies every logic operation as it is. But then we need to combine different logic operations to just get this kind of output. Okay, so what can be done? Now we know that we are borrowing a 1. So a 1 should come, right? Whenever there's a 0 and a 1, we should get a 1. Now how is that possible? So one way, why I'm saying one way is, in computer science, in logic, you can always find a new way as time goes. So at present, one way that is known to people is, we can do a not complement operation. A complement operation in this. So what happens when you do a complement operation? Let me write it here. When you complement this, what a complement operation inverts a bit, so 1 becomes 0, 0 becomes 1. So 1 0 0 1 0 becomes 0 1 1 0 1. Now this remains the same. Okay, let me write that down. So that is 0 0 1 1 0, and Now we know that we should get a 1 only this place, right? The third place. We should get a 1. Now look at these two inputs carefully. You need to get a 1 only when the two bits are 1. And there is an operation for that, AND operation. An AND operation. So what is the logic truth table of an AND operation? When you do an AND, 0 and 0 gives you 0, 0 and 1 gives you 0, 1 and 0, 1 and 0 gives you 0, only 1 and 1 gives you 1. That's exactly the meaning of AND. Only this and this. Only if both are true, this and this, both are 1, you'll get 1. Okay, so we see that is what we get here. Only 1 and 1, we should get 1. Only when we get 1 and 1, we should get 1. Okay, so we can do an AND operation. So when you do an AND operation, we get 1. When you're ANDing both, we get 1, 0, 0, 0, 0, right? Now this is exactly what we wanted, the borrow. Now, so first thing that you always wanted to do while subtraction is doing an XOR. Then you need to subtract the borrow. But there is one more thing that we need to do. That is, you see, as I mentioned here, when we are borrowing, we are not borrowing from the same term. I mean, that cannot be done. We need to borrow from the term, the digit that is consecutively to the left, that is to the consecutive left. We need to borrow from the digit that is to the left of it, right? So we need to, even though a borrow happens only when 0 and 1 appears, the borrow is happening from the left digit to it. You're borrowing it from here. So because of that, we need to left shift it. Left shift this one. So this 1 actually comes here. 1, 0. And that's what we want, right? Because 1, because that's what we want, right? So here also, 42 minus 27. We are borrowing it from the 10th place. So that is why we are actually borrowing at 10. And we have to subtract the 10. We cannot subtract a 1 because we cannot subtract a 1. Here also we cannot just subtract a 1. We need to subtract it from the place where it is borrowed. We're borrowing it from the 100th place, so we need to subtract 100. Here we are borrowing it from the 10th place, so we need to subtract a 10. Okay. Likewise, since the borrowing is happening from the next place to the consecutive left, we need to left shift it by 1. Left shift it by 1. And this gives you the required answer. Okay. This gives you the required answer. Let's check that. So the borrow here is 0, 0, 1, 0, 0. Now I'm left shifting the borrow by 1. Left shifting by 1. So I should get 0, 1, 0, 0, 0. Now I'm going to subtract that 0, 1, 0, 0, 0. So when I subtract that, I will subtract XOR, because we are trying to avoid the subtract operation. So when I'm doing an XOR here, I will get 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 1. But you see that again you don't get the answer. Why? Because there is 0 and 1 again. So we need to do this operation again. We need to find the borrow, left shift the borrow, subtract that borrow again. And only after that you will get this answer. So this is a repetitive operation. It's a repetitive operation. We need to keep on finding the borrow, left shifting it by 1, and then doing the XOR. Left shift the operation, left shift the borrow, do the XOR, left shift the borrow, do the XOR, and this needs to happen. So that is why, so to find the logic of this, I mean the code of this, we know that we need a loop, because this needs to keep on checking if there's a borrow, if there is a borrow, if there is a borrow. So what is the condition? If there is a borrow. So just write it here. If there is a borrow. Okay, so if there is a borrow, this needs to keep on going till it achieves something. So what is that? So we need a difference. You could give a difference variable to first do the basic subtraction, that is n1 or n2. Okay, then you need a borrow to check if there's a borrow. So you first invert the bits of n1, I'm sorry, and then you AND it with n2. You need not give the bracket, I just accidentally gave it. Okay, so difference is this: you found the borrow. Now this needs to keep on repeating. This needs to keep on repeating. So, but the next time the while loop finds the difference, it is going to check for n1 and n2. So your difference, the next time your difference should become n2, because after finding the difference and borrow, you need to subtract the difference and subtract the borrow from the difference, right? So what happens is, you have n1, you have n2, first you subtract them, you get some answer, and that is called diff. And you see that there is a borrow, so you need to subtract the borrow again, so you get some other answer, and that you can store it as your diff. And then if you have a borrow again, then you have to subtract that borrow again until your borrow becomes 0. You need to do that. When your borrow becomes 0, then diff becomes the answer. Then just the difference is enough. But till the borrow becomes 0, you need to keep on doing it. But every time the difference is found when we are XORing n1 and n2. So because of that, when the loop runs the second time, I want n1 to become diff. So I'll write n1 is equal to diff, and the second thing should be borrow. So I will write borrow is equal to, I'm sorry, n2 is equal to borrow. And if you remember right, we had to left shift the borrow. Remember, we need to from the place value of what we were borrowing. So we need to left shift the borrow. So n2 is equal to borrow left shifted by 1. That's it. Okay, maybe that's not it. And you need to find the condition. So what is the condition? Borrow is, if there is a borrow, that means borrow should be, while borrow is not equal to 0, the condition should be while borrow is not equal to 0. But we cannot, in the first condition itself, I mean, we don't have a borrow variable in the beginning, right? The borrow is, suppose, the borrow is actually defined inside the loop. So because of that, we'll just write while n2 is not equal to 0. Why n2? Because borrow's value anyways you're giving it to n2. So the first time, because supposing that you're not trying to subtract any value by 0, so you're giving two definite values, so this n2 will not become 0 in the first time. And then again, while the loop is running, in the first iteration, if borrow is 0, then n2 becomes 0 and it comes out of the loop, and it should return you n1. Why n1? I'm sorry, n1. Why n1? Because diff, the value of diff, you are storing it in n1, and diff is also a variable just declared inside the loop, so you cannot call it outside the loop. And the code which you posted is just an optimized version. Instead of declaring two variables, you directly store the values in n1 and n2. Basically both this code and the code which you posted is the same thing. So Yeah. So I hope it is clear.